Let's say we have 2 bunch of marbles. Let's say there are 5 here, there are 4 here, and we have 2 players. At each step, every player can choose one of these 2 sets, like let's say sacks, and pull non-zero number of marbles out of it. Okay? Someone lose if he can't move, like if both sets are empty. Who already solved this problem? Okay, a few. So let's start with this problem. For people who already solved this problem, let's say we have another set, like more than 2. Then let's see how we can do that. Like, let's start with 3 ones. How you can do that. And then if you still are able to solve it, you can go to the next problem in the WhatsApp group. So, do I need to repeat the problem? Everyone understood the problem? Repeat? Okay, so we have 2 sets of tokens and 2 players. So at each step, at each turn, the player chooses one of these 2 sets and removes some number of tokens. Now, who lose? The one that can't move, like these 2 sets are empty. So let's have some example. Like first player can remove 3 tokens from here, and then it's 2, then 4. Then second player removes one of these, and it remains like 4. Like every player can play in either sets. Like first player isn't forced to play on this or this. He can play with any of them. And then consider that first player comes and removes all this, and now whatever second player chooses, first player chooses the other one and he'll win, because second player faces both empty sets and he'll lose. Okay, is the problem clear for everyone? Okay, so now let's start thinking and we'll continue from there. You want to tell solution? Okay. You want to say something else?
You said these 3 problems, but the link to this one, the last one, is not really good.
Wow.
Yeah, I asked another guy as well.
Very strange. Wait. Oops. Coach Force is down. It's very strange, but yeah. Just wait, sorry. I'll be back. So I want to send a fresh link. As Coach Forces is down right now, I don't know why. I sent link to the 3rd problem from VJudge, so you can read the problem at least on VJudge, and tomorrow you can submit it. Okay, someone was something. Say something. Everyone solved this version with just 2 sets. So people who already solved this problem, raise your hand. Okay, almost everyone. So this is easy. Like I start when I want to start with some kids, like how to start like Olympiad of informatics, like high school, like middle school actually, kids like 8th grade, 7th grade, something like that. I start with this problem. So like, and I give them real like tokens to play with their friends, like they are real kids, like, right? You should start with them with some real games to play, and not to fear from like trying to hide that they should learn C++ very soon and a lot of hard problems and all. So you should like fool them somehow. So I start with some game and it's funny, but we never go for more than 2 sets for sure, because problem becomes like much harder. So the strategy is simple. If the number of tokens are not equal, make them equal, then whatever second player do on the sum set, you can do on the other set, and the game goes like this, and you finally win, because if there was some token in some set, there is still some token in another set because they were equal, and you have chance to remove it, so second player will someday lose. And if the number of tokens are equal, then you'll lose, because whatever you do, second player does on the other set, and so on, and you'll lose finally. So let's solve this problem for more than 2 sets. For example, 3 or more. Like if you solve it for 3, you can use the same strategy for more. So who already solved this problem, which is called the Nim Game? Who solved it already? Okay, a lot. But yeah, let's have some time to think and solve this problem. Thanks for watching. If you found this video useful, please like, subscribe, and ring that bell. By the way, YouTube thinks the video down here is just perfect for you. Give it a watch and let me know in the comments.